Hello, Daniel Rioux. Thank you for coming to our series of mining interviews, for
Thank you.
participating. Today we're going to talk about density measurement and control in the thickening process. First of all, it would be nice if you can give a little introduction about yourself.
Sure, my name is Dan, and I'm an instrumentation technologist in a nickel mining company in Canada. And I'm very lucky to have worked with some very talented people in both the pulp and paper and the mining industries on some really challenging controls. So today I'm going to talk about some of my experiences with installing and controlling density gauges, and we're going to use thickener underflow as an example.
So what would be the first step for implementing the density measurement and control?
Well, the first step is the actual installation, and that's pretty much the most important one. So picking a proper location, setting up a proper orientation of the meter, depending on the technology used, proper pipe sizing. They're all key components in a proper installation.
And then the next point is you're ready to use the selected density meter for process control. So if you have set all those things, you're ready to start?
Well, so not quite typically. Now at this point, you have to make sure of the setup details of that meter. So it's very important that dampening factors be correctly selected. It's very common. I've seen a lot of times where people will try to over dampen reading because it gives a nice stable result. Sometimes the reason that result is cycling is real. So in attempting to hide what seems like process noise, right, an erratic reading, where they say, no, it should be constant. It should be, but you have to be careful not to over dampen. And what's actually going to happen potentially, and I've seen this quite a few times, is you're going to dampen the reading so much that it looks so nice, but it's truly changing behind the scenes. It's truly suffering some short of like a short cyclical action, and that could be a mechanical, it could be the result of the pump sending a pulse while the dilution flow keeps coming at a constant rate, and therefore it introduces a slightly varying density in a very quick, rapid cyclical fashion. But it could also be that you have mechanical interactions, such as discharge from the rakes within the thickener that are sending product into that inlet line into the pump. And so as those pulses come in, you can have a very changing density that you're unaware of. And so when you try to calibrate the meter and compare it to a sample, well, the sample might be accurate right now, and then 30 seconds from now, completely off. And then, and then the other way, 30 seconds later.
Like saying like we want the average of 20 seconds or so.
Well, that is what, yes, that is what the dampening will do. And that's the problem, is that you need to see the real one because you're trying to chase something that is moving. And so you need to have that very tight, updated information as to what is happening.
If you have the unfiltered one, can you also see easily or more easily identify problems in the process? If you have the
it's possible, yes, yeah. If there's things happening that you're unaware of, you should know about them. So I definitely would rather we see the raw value or almost unfiltered, maybe a couple seconds worth of filtering, and then from there, maybe apply a slightly heavier filter to the actual controller variable. But the one that we would see, I would want to see as unfiltered as possible so that we can make educated decisions about how we're going to calibrate and how we're going to correct and identify problems within the process, right?
Yeah.
So, yeah, so definitely there's something to be said about seeing the raw signal or almost unfiltered signal versus feeding a controller a heavily attenuated or dampened or smooth signal. It's better for the controller to see a smooth one, because the smooth signal prevents unnecessary valve wear. Because if you think about it, you know, if you keep saying, okay, the density's high, oh, it's low, it's high, it's low, well, the valve keeps hunting, and you're going to wear the valve. So
makes sense.
So it
makes sense.
Yeah, it makes sense. But on the same token, if the density is going up and is quite high, and you're still saying, no, it's not so bad, well, the controls can't correct for it, right? So you want to have a minimum amount of dampening, but try to avoid unnecessary reaction to process noise.
Yeah, so in this case, you have to, this is all about setting up the instrument the way it should be set up for your process. A little bit of averaging or dampening of the signal is advised, like you said, like maybe 3 seconds or 5 seconds. But for the control system, you might want to have a longer average, or
just make sure it's smooth, you know.
Yeah, that's not that the valve is opening and closing all the time, like.
If it's a known cycle that's going to happen, let it happen, you know. We want to control the average of it. We're not going to be able to correct something that cycles every 20 seconds accurately. We're just going to wear our equipment out. So,
but if it's like if those things happen like once in a half an hour, like a sudden peak, and then you want to compensate, or if it's like every 10 minutes,
Sure.